the project development arm of BBI, and I've known Mark for many years. I am learning more about the D3MAX LLC technology. It's there to commercialize corn fiber to ethanol technology, not that dissimilar from some of the other technologies. The D3MAX process will convert wet cake to cellulosic ethanol. D3MAX plans to license its patented process to dry mill ethanol plants throughout the U.S. Mark's responsibility include the final design of the process, managing technical services, and overseeing the sales of licenses. As I mentioned, Mark is the current and longtime VP of Project Development with BBI International, where he oversees the consulting. Mark put in some time at NREL, some other companies that you told me about yesterday that I hadn't realized you had worked for, and I think a very detailed understanding of ethanol production from starch and sugar and lignocellulosic feedstocks and how the economics of those things work out. You got a BS degree in chemical engineering from Stanford University. Please welcome Mark. The project development arm of BBI.
Thanks, Paul, and good afternoon. As Paul said, I'm going to provide an overview of D3MAX. D3MAX is a new company formed by BBI International to commercialize our patented corn fiber to ethanol technology. BBI began development of this technology back in 2006-07. I had a small staff of chemical engineers that worked on this for a couple of years. We worked with Genencor and Novozymes and NREL to test and develop the technology. We received a patent in 2012. The patent covers a broad range of fermentation residuals, but we're focused on the conversion of corn fiber and residual starch to ethanol. And our goal is to license the technology to at least 50 of 200 dry mills out there. I think those are pretty lofty goals, but I think when you see some of the numbers here, you'll understand why I believe this technology will be implemented on a very wide scale. D3MAX technology can increase the ethanol production of a dry mill by 10%. So if you have a 50 million gallon year plant with D3MAX, it'll produce 55 million gallons. Corn oil recovery or available for recovery will go up by at least half a pound per bushel. DDG protein is increased from 30 to about 40%. The volume goes down about 20%, and along with that, your dryer energy use is reduced by about 20%. And you can, because of that freed up dryer volume, if the rest of your plant can handle it, you can increase the grind up to 20% or more, but again, that depends on the rest of the dry mill and how it's sized. Later, I will mention Enogen corn, and I think that would be a good addition for this technology as well as Celerate's technology. The technology generates D3 RINs, so we're talking about cellulosic ethanol, and I think the most important thing is I'll show you some financials that show that you can increase your bottom line by up to 20 cents a gallon for all gallons produced. So a 50 million gallon a year plant that implements this could increase their net income by as much as $10 to $11 million, which works out to 20 cents a gallon for all the gallons produced. So that's the driver I see that is really going to move this kind of technology, corn fiber to ethanol, into the industry, I think, fairly rapidly. D3. So it's my version of a dry mill ethanol plant. You take corn and grind it in a hammer mill, run it through a slurry tank, cook tank, liquefaction, and then into fermentation. That feeds the beer well, and you go into distillation, emulsives, and then you have 200 proof ethanol. A good ethanol plant will produce about 2.8 gallons per bushel ethanol yield from that bushel of corn. And you can see, pointer's top. Yeah, you can see at the bottom of the beer well, the whole stillage comes out. That goes through a decanter, produces a thin stillage. and wet cake. And it's this wet cake that is our target feedstock. And the reason is because it's high in insoluble solids. That's where most of the fiber is that we want to convert to ethanol. So we can minimize the amount of water going into the D3MAX plant and maximize the solids loading. That wet cake is about 40% fermentable sugars by dry weight. So here's the same dry mill with the lower shaded portion is the D3MAX plant. And if you look at it, it really looks a lot like the dry mill. The difference is in the individual process steps, the pre-treatment is a little different than you would do in a dry mill. The enzymes used are different. But we basically start with the wet cake that goes to a holding tank or day tank that goes through a jet cooker to increase the temperature and pressure. That goes to a cook tank where we hold it for 5 or 10 minutes. This will convert the ribose and ribena and xylan to soluble sugars, which will then be fermented to ethanol later on. But then after the flash tank, we go into the combination hydrolysis fermentation tank. So we first do a hydrolysis step where we fill the tank, add a cellulase enzyme, and convert the cellulose to glucose. And then that same tank, we add the co-fermenting yeast and ferment the glucose, xylose, and arabinose, giving us 10% increase in overall ethanol production. So we then go into a new distillation system. The beer that comes out of this goes into a new decanter, and that gives you the wet cake with 40% protein. And now, instead of about 50% of the oil, it's only about 25% of the oil in this more concentrated wet cake. You have a second thin stillage stream that goes back, combines with this one, and goes to the evaporators. So in here, we're looking at about 3.1 gallons per bushel overall yield, and about 50 gallons per ton of dry weight of wet cake. So some of the advantages. The advantages are quite numerous. I just listed some of the main ones here. The wet cake fiber is 3 times more concentrated than the fiber in whole stillage. That results in significant reduction in the equipment size and the energy use to heat up the streams going through the D3MAX process. And that results in lower capital costs and lower operating costs and lower energy use. D3MAX uses a co-fermenting yeast with GRAS status. The DDGs are suitable for use in both monogastric and ruminant animals. The yeast also ferments all 3 primary sugars in corn fiber. That's the glucose, xylose, and arabinose. So we're maximizing the ethanol yield and going after all the fermentable carbohydrates. And like Delane said, this is very, very similar. Because the fiber has gone through the ethanol plant and essentially been cooked or pre-treated in the ethanol plant, this process requires very mild pre-treatment. It means lower temperatures, less degradation products produced in pre-treatment. So you have a more efficient fermentation with less problems in fermentation. So using fiber that's gone through the ethanol plant is a very, very important point of our technology and an important benefit because it lowers the cost of pretreatment, both in capital cost. You have lower pressures involved, lower temperatures, and therefore lower operating and lower capital costs for that equipment. Also, because the pretreatment is so mild and the corn fiber has been essentially pre-treated in the ethanol plant, the enzyme dosage is much less than what we've seen in corn stover and other what I'd call raw biomass that is just brought in from the field and converted to ethanol. Novozymes gave a presentation at the Fuel Ethanol Workshop where they demonstrated the corn fiber requires 1/3 the enzyme as corn stover. So that's a huge cost savings. The cellulase enzymes are still relatively expensive, but with corn fiber, the dosage is much, much, much less. So, and the other important thing is the freed up dryer capacity, along with the energy savings if you don't increase the grind to take advantage of that. But with that dryer capacity freed up, if that's your bottleneck in your plant, you can now grind more corn and produce both more starch-based ethanol and cellulosic ethanol. So here's the output of our techno-economic model for a 100 million gallon year ethanol plant. We ran two scenarios, one with 100 million with D3MAX, and then a plant with 100 million where they've increased the grind 20%. So that 100 million is now producing 120 million gallons. You get slightly more cellulosic ethanol because you have more corn fiber. So you can see the net earnings. I didn't put in all the details of revenue and everything, but the basic assumptions of this were that ethanol is at $1.50 a gallon, D3 RINs at about $1.50, and corn oil at about 30 cents a pound. So I think the bottom line here is the internal rate of return for a 50% equity investment, 122% for the 100 million gallon year plant, and for the plant that's increased the grind 135%. And I don't see anybody shaking their head, but those are pretty astronomical returns. And I have to say the assumptions on D3 RINs might be accurate, might not be that high, but the real point here is the feedstock is free. So there's no feedstock cost. So what we're paying for is some energy, the enzymes, the capital, and a little bit more labor to run this plant. So that's why, we're able to predict such a high return on investment. The line right below that, the IRR without the D3 RIN, so if we zero those out, you're still looking at 50% internal rate of return, which is, again, a pretty fantastic return. Down at the very bottom here, I've calculated some actual ethanol production costs because there is no feedstock cost. The actual production cost is 67 cents a gallon. If you add in administrative and overhead costs, that goes to 75. If you add in debt service and depreciation, you're looking at $1.14 a gallon. And to me, that says that this type of process will be very profitable in good times and bad. Should be able to withstand the ups and downs of the ethanol industry. And again, net earnings on all gallons, an increase of 21 cents per gallon. So here's our plans for rollout. We don't have a commercial plant. We are going to build a portable demonstration facility that we can take to ethanol plants and demonstrate it with their wet cake on site. I've met with a lot of ethanol plants, and that's been a kind of a common theme is demonstrate that it works with my wet cake. And I think the wet cake can vary somewhat from plant to plant, but we're going to have a portable unit in about 6 months, and we'll begin taking that out and demonstrating the technology. After that, we're going to design the first plant, first D3MAX plant. It should be ready for licensing about 12 months from now. It is a bolt-on technology, so there won't be long downtime required when it's installed at an ethanol plant, just some fairly straightforward tie-in to the existing plant. And construction, I put 12 months. I would hope it could be faster than that, but we're planning on about 12 months for construction. And we've looked into it. We can provide a process guarantee with a full insurance wrap if that's necessary. I'd rather not go that route. It's quite expensive, but we can do that. So this is maybe a little redundant, but I really wanted to hit home that the benefits are really numerous. There's even more beyond this that I would call maybe secondary benefits. But this type of technology, I think it's going to be implemented on a big scale because of the benefits are so large. I won't go through them all again. So this is. So that's the end of my presentation. I have a booth right on the other side of this wall. I encourage you to stop by if you have questions, if you'd like to learn more about technology. And thank you. very much. So that's the end of my presentation. I have a booth right on this